Hey, MathCook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathcook.com. Let's MathCook it up. This question says, for the parabola y plus 3 squared equals negative 12 times x minus 4, find the vertex, focus, directrix, and axis of symmetry, then graph. So in this case, we have the y's being squared. So let's take a look at a little diagram that will help us kind of figure out which direction this parabola is going to open. So here's our four possibilities. So in this case, we have the y that's being squared. So we know it's going to be this parabola here, which means the parabola is either going to open right or left, depending on if a is positive or negative. So let's take a look at our equation here. And we can find our vertex. I'm going to bring down all the things that they're asking for. So the vertex is going to be the opposite here and the opposite of this guy. So it's going to be 4, comma, negative 3. Notice we always do the x first, then the y. So 4, negative 3. So we'll write that down here. 4, negative 3 is our vertex. So next we want to find out if what direction the parabola is opening. So because a is going to be a negative number because this is negative, that tells us that the parabola is going to be opening left here. So we're going to have a leftward opening parabola. And now we need to find what a is. So to find a, we set whatever's in front of the x term here, we set that equal to 4a and solve for a. So in this case, we have a negative 12 here. So we're going to set 4a equal to negative 12. If we divide both sides by 4, we get a equals negative 3. So a is a really important distance. A is the distance from the vertex to the focus. Now here, this is just a general look at a parabola. This one happens to be going up, but you would basically tilt this parabola on its side and have it go left. So a is going to be the distance from vertex to parabola. In this case, it's negative 3. So we're going to go left 3. All right, so I'm going to go ahead and erase this chart here. So that way we have room to start graphing our parabola. All right, so let's start off by graphing our vertex 4, negative 3. So we're going to go right 4, down 3, which will take us to like right there. So we're going to do that here. So that is our vertex. I'll label that as that's our V. And then our focus is the next thing we want to find. So A is negative 3. So remember, we're going to go 3 to the left because it's opening left. So we're going to go 1, 2, 3. So our focus is going to be right there. So I'll draw a point here. So our focus is going to be at 1, comma, negative 3. So there's our focus. I'll go ahead and write that here. 1, comma, negative 3. All right. Next, we want to find our directrix. So since A is 3, we're going to move, instead of left 3, we're going to move right 3 now. So 1, 2, 3. Now our directrix is going to be over here. So I'll do that in red. So that's going to be at 7. And then we're going to draw a line. It's a vertical line through 7. So it's going to go up here like this forever. All right, so there's our directrix, and I'll go ahead and label that. So that line is going to be x equals 7. And then we'll go ahead and label that on the left here. So x equals 7 is our directrix, a vertical line here. Next, the axis of symmetry. All right, so the axis of symmetry is the line that runs right through the vertex and the focus. So we'll go ahead and do that in green here. So we're going to go like this here. So our axis of symmetry is going to run through negative 3 and go right through the vertex and the focus. So what is the equation of this line? Well, it's going to be y equals negative 3. So I'll write that here, y equals negative 3. All right, so we have our vertex, our focus. Next, we want 2 more points on the graph. So we are going to get our focal length. The focal length is the absolute value of whatever number is in front of the x here, the coefficient in front of x. So I will write here the focal length is going to equal the absolute value of negative 12. which just equals 12. So there's our focal length. So that tells us that the distance from these 2 points here, this point and this point, is going to be 12. So you're going to start at the focus. So there's our focus. And then in this case, well, in this example here, it goes, the parabola is opening up. So you'd go left and right in half of 12. So we'd go left and right 6. But in our case, remember the parabola is opening left. So we're going to go up and down 6. So if we're at -3 right now, if we go up 6, that'll take us to 3. So our point here on the parabola will be at 3. And if we go down 6, we'll be at -9. So 1, 2, 3, 4, 5, 6. So here at -9. So these 2 points are really instrumental for graphing the parabola because they kind of guide where the parabola goes. These 2 points tell you how wide or narrow the parabola is. So we're going to graph like this. So this is a pretty wide parabola. So it kind of goes like that. There it is. So there's our parabola there. And there's our, let's go ahead and label our parabola. So this guy was the curve y plus 3 squared equals -12 times x minus 4. And then our focus, we can go ahead and label that. Our focus was 1, -3. And then our vertex was 4, -3. All right. So there is the graph of our equation, our parabola here, y plus 3 squared equals -12 times x minus 4. Let's also label the axis of symmetry, just to completely label this diagram. So that was y equals -3. All right, there it is. There's our final graph.
Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.